So this is PECVD NPE 4000 by NanoMaster. This is the main machine, main chamber in which the PECVD will be performed. You can see these are the gas lines which are coming to the chamber. This is the RF power supply, and this is the chilled water supply. The gas supply lines and mass flow controllers are inside this. So gases are coming from the gas bank, and this is the control for the individual gases. For each gas we have one mass flow controller, and that mass flow controller is controlled by this PC. This machine has three basic components. One is gas supply, one is this main machine, and another one is chiller. So these are the samples for our PECVD deposition. We are going to deposit silicon dioxide through PECVD process. These are the silicon wafers which we have thoroughly cleaned, followed by acetone and IPA ultrasonication. Then we dried it in nitrogen stream and heated it up to 150 degrees for 10 to 15 minutes. We have placed this on this metal grid. You can see the samples, and we put the Kapton tape to immobilize it over the metal grid. So in these circles the silicon dioxide deposition will be performed. Now I am going to demonstrate PECVD equipment and PECVD process. So this is the main power supply of the PECVD equipment. I am going to turn it on. This is the main power supply of the machine. I am going to turn it on. This is the chiller of the machine, which is already turned on, and it is maintained at 19 degrees Celsius. You can see these blue lines containing chilled water supply, which is required for this machine. And nitrogen are directly coming to back side of the machine and going inside the chamber. This is the main control PC which will control the PECVD equipment on all the processes. Now it is on, and this is the RF power supply, platen heater and chamber heater controls. Now to control this machine we have NPE 4000 software. I am going to open it by double clicking it. So you can see the chamber pressure and the barometer pressure gauges, the chamber pressure and barometer pressure values, the gauge for turbo speed. You can see the turbo speed is 0 right now. Again the utilities like cooling water, compressed dry air, backing pump, turbo pump and venting chamber. For this machine's operation you require chilled air, compressed dry air, vacuum pump and turbo pump. So I have already put the password which enables all these tabs: vacuum tabs for for venting down or opening the chamber, operator mode, process mode and engineering mode. So first we are going to pump down the chamber and do a cleaning. So before doing any deposition we are going to perform the two-step cleaning. First with IPA and then followed by a plasma cleaning. So I am taking IPA in a lint-free tissue and gently wiping down the surface. So you need to gently wipe the platen, the inside chamber walls and these rings. you have to be very careful with this gas distribution rings. These are very delicate. Just hold them with one hand and very gently wipe with the lint free cloth. Then shower head, very gently without disturbing the rings. Now I am going to close the chamber. After closing the chamber, ensure whether it is properly fitted or not. Yes, I think it is properly fitted. I am going to pump down the system. So I started pumping down. You can see the backing pump is on and the chamber pressure is getting reduced. So you can see now the chamber pressure is close to 6 into 10 raised to the minus 2 torr, which is a good value to turn on the turbo. So backing pump will provide the required vacuum for turbo. Once it is attained, you can turn on the turbo. As you can see, the turbo speed is getting increased. The chamber pressure is reduced further. As you notice, we have two pressure gauges here. One is this one, which says chamber pressure, and another one is baratron. This chamber pressure has a broad range, but it is not highly accurate. For process, we read this baratron pressure, and for overall pressure changes or broad ranges, we are referring this chamber pressure. For degassing, I am putting chamber heater on. And platen heater on. So this is the set point or the set temperature for platen as well as the chamber. These are the actual temperature of the platen as well as the chamber. Now we will wait for some time, so the pressure will be stabilized and we will attain the required temperature both at platen as well as the chamber. Now you can see the platen heater and chamber heater are close to 150 degrees Celsius. So now we can start our cleaning process, plasma cleaning process. For that, I am reducing the turbo to 20% by setting this value in this panel here and then enabling it. So now you can see the turbo speed is getting down. So as the turbo speed is reducing, you can see the chamber pressure is slowly rising. So you can see this part of the screen is divided into gas flow control, pressure control and power supply, RF power supply control, and then you can put a timer to the process, and then you can do some purging of silane as well as ammonia if required. So we will wait for some time till it will reach to 20%, and then we will switch on argon and CF4 gas and perform a plasma cleaning. So now you can see the set point of the turbo has been achieved to 20%. Now I am going to switch on the argon supply very slowly. I have put 10 SCCM as a set point of argon supply. Now I am turning it on. You can see the increase in the pressure from -3 to it reached to -2. I am increasing the argon flow to 20. Now I am gradually putting CF4 starting from 20 SCCM, the RF power supply. Slowly increasing the CF4 to 30 SCCM. 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 Finally 80 SCCM. I am putting RF power as 150 watts. Now as I turn on the RF power supply, I am expecting a plasma glow here. So after turning on the power supply, you can see a pink color plasma. If you can see here on this power supply tab, carefully check this RF reflected power. This should not be beyond 10% of the set point. So right now it is around 1 watt, so it is well within the limits. Now I am putting the timer . 10 minutes, and I am starting this timer. So you can see the remaining time. After this much time, the RF supply and the gas flow will be stopped. So right now we are performing the chamber cleaning with CF4 and argon plasma. This is to ensure, this chamber cleaning with plasma is to ensure removal of previous contamination. So now you can see around 30 seconds are left. After 30 seconds, the software will automatically cut the RS supply as well as the gas flow, and the glow will be off. So you can see the glow is not present, and the RF power supply as well as gas flow is switched off. Again I am putting turbo to 100% so that any residual gases will be thrown out of the chamber, and after that we will open the chamber and we will keep our samples. So you can see the turbo is at 100% speed and the chamber pressure is quite low, 3 into 10 raised to power minus 5 torque. We will wait for 5 minutes and then we will start the venting process, followed by opening of the chamber. So now we are going to vent the chamber. So for venting I am clicking this press to vent button. Now you can see the turbo speed is slightly getting reduced and the chamber pressure is slightly increasing as the turbo is getting reduced. And the pressure profile, you can see it here. Now you can see venting chamber indication is on. The chamber is under the venting, and now I can open the chamber. So as I have told you before, this is our sample which is kept at the back, and this is the metal grid. We are going to keep this inside our chamber. So the wall as well as the platen is quite heated, so I am going to use a tweezer, and very slowly and carefully I am going to put it inside the chamber. So my sample is at the platen, exactly at the middle. Now I am going to close the chamber. Ensure the chamber is properly closed, no mismatch or leaks. Yeah, it is properly closed. Now I am going to pump down see the backing pump and turbo pump is in off condition right now. The moment I'll start this pumping down process, you can see the backing pump is on and the chamber pressure is getting reduced. So this backing pump is basically creating the vacuum inside the chamber, which is required for a turbo pump to get on. So we will wait till 10 raised to power minus 2 torr and then we will enable the turbo. So it is 2.8 into 10 raised to power minus 2 torr. I am enabling the turbo. You can see the turbo is on and you can see the turbo speed here in this dial and this tab. So turbo speed is getting increased slowly and so the chamber pressure is going down. Once again we have two pressure gauges, one is representing the chamber pressure and one is the barotraton pressure. The chamber pressure, this gauge has a very broad range but it is not very accurate. So that's why for overall, for broad ranges we are reading this chamber pressure and for process pressure we are going to reach this barotraton pressure. Now we are going to wait till the turbo reached 100%. So turbo is now at 100% and the chamber pressure is still going down. We will wait till few more minutes till the chamber pressure gets stabilized and then we will start our process. So for deposition we require the platen temperature around 350 degrees Celsius. So I have set the platen temperature 350 degrees Celsius. Current temperature is 91 degrees Celsius. It will take some time to reach 350 degrees Celsius. Hopefully by that time the chamber pressure will get stabilized. So we will wait and then once the platen temperature and the chamber pressure achieved, we will start our process. So the platen temperature is about to reach 350 degrees Celsius. It is slightly higher, it will get stabilized. By the time I am reducing the turbo speed to 20%. And then we will start the process. So as I enable this turbo speed 20% button, you can see the turbo speed is getting reduced. So you can see the barotraton pressure is around 0.37 torrs. I am putting RF supply is 150 watts. Before turning on the process, I am checking the utilities, the DI water, compressed dry air, backing pump and turbo pump. All are in running condition. The chamber pressure and the chamber heater as well as the platen heater are working fine. Now I am going to turn on the RF supply. As the RF supply is on, you can see a plasma, slightly different color plasma. Now I am going to time the process around 45 minutes and start the timer. So timer has been started. After 44 minutes 50 seconds the RF supply and the gas flow will be stopped and then we will open the chamber. Now since the chamber, the platen temperature is at 350 degree, it will take couple of hours to cool down to room temperature. After that we will open and take out our sample and perform the cleaning once again. So this is the PECVD process we have demonstrated.